Welcome everyone, my name is Mauricio Somaweb from Finisterrae University here in Chile, and today I will be presenting joint work with my friend Bernardo Quiroga from West Virginia University. So in this paper, we studied the strategic interaction between a downstream firm, which I will call the retailer, and an upstream firm, which I will call the manufacturers. So we assume that upstream manufacturers must take the decision whether or not to make costly capacity investments to meet downstream demand. Of course, these investments are justified whenever market demand is high. If market demand is low, then the investments are not justified. The main problem in this context is that by being closer to the customer, retailers have better market information than manufacturers, and as such, manufacturers depend on information disclosed by retailers. So this introduces a clear bias. Retailers will have the incentive to push for excess capacity even when market demand is low. And this is one way in which inefficiencies might arise. However, of course, manufacturers are not blind to this bias, and they will optimally decide to be less attentive to retailers' information disclosure and opt to rely on their own information acquisition technology. Mechanism design has been the traditional workhorse to align incentives in the literature of supply chain management, and this is usually achieved through a contractual relationship between manufacturers and retailers. By building on the theory of information design, we are able to provide a novel and non-contractual mechanism for coordination. And this is done mainly through the threat of verification. Okay, so let me walk you through a worked example of our model. Manufacturers are dealing with the decision to either build or not build capacity. The utility function or the payoff function of manufacturers is state dependent. There is an unknown state of the world, which we represent here by the letter theta. So theta might equal uppercase H, meaning a state of high demand, or uppercase L, meaning a state of low demand. And so basically the manufacturer gets a payoff of 1 whenever he makes the right decision. That is, if he builds capacity when state is high, when demand is high, or if he doesn't build when demand is low. And he gets a payoff of 0 whenever he makes the wrong decision. And from here on, we will denote with mu the probability assigned to the state of high demand. The retailer's payoffs are state independent. They are only a function of the manufacturer's action. So basically the retailers get a payoff of 1 whenever manufacturers build capacity, and they get a payoff of 0 whenever they don't. So by comparing these two payoff functions, it is clear that there is an incentive misalignment between retailers and manufacturers. Okay, so let me walk you through the timing of events in our model. The first event in our timeline requires the retailer to commit to a particular persuasion strategy. This is a common assumption in the Bayesian persuasion literature. Otherwise, we're just talking about a typical chip talk game. So once the retailer commits to his disclosure strategy, then players are matched, meaning retailers and manufacturers, and they both share a common prior mu0. After players are matched, then comes the information disclosure stage or the persuasion stage, in which the retailer recommends either building or not building capacity. After receiving the information from the retailers, beliefs are updated from mu0 to mu1, obviously via Bayes rule. And following the information disclosure stage comes the information acquisition stage. So at this stage, manufacturers are able to acquire further information in order to either verify or contradict what they have learned from retailers. We assume that information acquisition is costly, and by following rational inattention literature, we assume that the cost of information is proportional to the expected reduction in uncertainty. After acquiring information on his own, beliefs are updated from mu1 to mu2, the manufacturer makes a decision to build or not to build, and profits are materialized. Okay, so now I will try to present to you the main intuitions of our model by using a simple animation. So here in yellow, I am representing the retailer's expected payoff as a function of manufacturer's beliefs. Clearly, if beliefs are less than 1/2, manufacturers' expected payoffs are maximized by choosing not to build, and this yields a payoff of 0 for the retailers. On the contrary, if beliefs are greater than 1/2, then manufacturers optimally choose to build, yielding a payoff of 1 for the retailers. The question we then ask is if information disclosure is able to improve the retailer situation. And in fact, it can. So if prior beliefs are greater than 1/2, then retailers receive the highest payoff, and therefore there is no need for information disclosure. So the payoff function will look just the same for beliefs above 0.5. So let us now consider the case of a manufacturer with belief below 0.5, for example, 0.25. So by disclosing just enough information, the retailer can induce posterior beliefs of 1/2, and therefore convince the manufacturer to build capacity. And notice here that I am assuming that whenever the manufacturer is indifferent between building and not building capacity, he will build capacity. So in other words, I am focusing on the retailer's preferred equilibrium. Now, given that the average posterior must equal the prior, sometimes the information disclosure will convince the manufacturer that there is no need to build, in which case retailers would get a payoff of 0. So by using this strategy, retailers can achieve a higher payoff than before. The optimal payoff function is therefore the red line below 1/2 and the yellow line after 1/2. And as it is represented in this graph, the expected payoff is exactly the same as the probability of recommending action 1, or the probability of recommending to build capacity. Now, can the manufacturers benefit from private but costly information technology? Once again, the answer is yes, and let me show you how. So, information is more valuable to any decision maker when uncertainty is higher. And in our model's context, uncertainty is maximized at beliefs 1/2. This means that for any given unit cost of information, there will be a neighborhood around these beliefs where manufacturers will find it optimal to reach for their own information technology. And this is represented here as the green interval labeled learning zone. The cutoffs μh and μl are beliefs below or above which information is too expensive, and therefore the manufacturers will rationally be inattentive to their own information technology. So information will be acquired only in the green learning zone, and outside there will be no information acquisition. By using a similar argument to the one described before, we are able to find the retailer's maximum payoff. In this case, it is the red function shown in the figure. Notice that the communication is now more transparent in the sense that whenever manufacturers decide to build capacity, they are now more convinced that this is the optimal course of action. And this is because the cutoff value μh is higher than 1/2. So this points to our main conclusion, which states that retailers will always crowd out information acquisition. In other words, induced beliefs after the persuasion stage are such that manufacturers optimally decide not to verify what has been disclosed. And therefore, and this is another main conclusion of our paper, we conclude that the value of information is derived not from its usage, but mainly from its availability. Okay, with this I conclude my presentation, so thank you all for your attention.